right, we are going to look at multiplying radicals today. Key thing to remember is that like parts get multiplied together, and the biggest thing you have to make sure of is that when you finish multiplying, you absolutely simplify. So, quick reminder, the square root symbol I have here, that's called a radical. The insides are radicand. You multiply the radicands together. We'll talk about coefficients in a little bit. So, for my first example, let's just say we're looking at the square root of 3 times the square root of 6. All we need to do is say this is the square root of 3 times 6. Now at this point, there are several different ways you could go about getting a final answer. For now, I'm just going to multiply these together and say I have the square root of 18. Now I need to simplify that. Showing you a few different ways to simplify, but let's just go with largest perfect square. What's the largest square number that we can think of that goes into 18? Well, the largest square number smaller than 18 is 16. Doesn't work. Next square number after that going down would be 9. Oh, we can write this as 9 times 2. So the square root of 9 times 2. Well, square root of 9 is 3. Square root of 2 is the square root of 2. We've got our answer. So the square root of 3 times the square root of 6 is 3 square roots of 2. If you have a different way to simplify that and come up with the same answer, you're probably good to go. All right, so let's look at another one. Square root of 4 times square root of 5. Now, some of you would be tempted to do exactly what we just did, and it will work. If you go through and say, well, this is really the square root of 4 times 5, which is going to be the square root of 20. And then we can say, well, what's our largest perfect square that goes into 20? And we can go through our process and find that it's 4. Square root of 4 is 2. And then we still have a square root of 5 left over. So there's our answer. Now, hopefully some of you noticed there might have been an easier way to do that. If we go back and look at the original, this is a perfect square for the radicand. Square root of 4, we can do that immediately and say, you know what? This is 2, and this is just the square root of 5. We get to the same answer. So if you're always on the lookout for something that's already a perfect square, you can save a little time. All right? So what I want you to do now is try one of these on your own. All right, so here's a problem. Square root of 6 times square root of 10. Take a moment, pause the video, and see if you can come up with the answer. All right, so if we go through our process, first thing we're going to do is multiply that 6 and 10 together. So now we have, hey, this is really the square root of 60. And now we can go through and start to figure out what is my largest perfect square that goes into 60. And in this case, it's going to be 4. So instead of 60, I'm going to write 4 times 15. And the square root of 4 is 2. And then square roots of 15. And we have our answer already simplified. Here's one more for you to try. Square root of 3 times square root of 25. Take a moment, pause the video, and then come back to check. All right. So hopefully you are observing that the square root of 25 is a perfect square. So we can actually just replace that with a 5. Notice the 5 is no longer in the radical, it's outside. So this is really our answer, but we got to write it the way we normally would. The coefficient's going to be first, the radical last. 5 square roots of 3. If you multiply it together, you wind up getting the square root of 75. But when you break down the square root of 75, you are going to wind back up at 5 square roots of 3. All right, so what happens if we have a coefficient up front? I mentioned that at the beginning we would get to this. Really, nothing major. Multiplication is commutative. You can move things around. What you have to realize, when you see 2 square roots of 5, that really means 2 times the square root of 5. 3 square roots of 5 means 3 times square root of 5. Our commutative property tells us that with multiplication, we can move things around. It will not change the answer. So I can say this is really 2 times 3 times square root of 5 times square root of 5. Well, 2 times 3, that's easy. It is 6. Times square root of 5 times square root of 5. If you recall, you multiply the insides. So 5 times 5 is 25. Square root of 25. Well, at this point, we can go through and say, what's the square root of that? 5, and we've got 6. 6 times 5 is 30. So 2 square roots of 5 times 3 square roots of 5 is just 30. Not every answer is going to have a radical in it. Sometimes you get nice numbers. All right. So let's take a moment and try this. You try. Pause the video. Okay, you were supposed to pause the video and actually work it out, not just wait for me to do it. All right. So we're going to start by multiplying 3 times 5 and then multiplying our square root of 8 by the square root of 10. 3 times 5 is 15. 8 times 10 is 80. And once again, if you start checking your perfect squares, what goes into 80? If you start with 64, work our way down. 64 doesn't work. We try 49, it doesn't work. We try 36, nope. 25, nope. 16, 80 is 16 times 5. So we have 15 times the square root of 16 times square root of 5. Well, square root of 16 is 4. So now we need to do is 15 times 4. And we get 70 square roots of 5 for our final answer.